In this video, we will build a simulation model to explore how different checkout configurations can affect customer flow and waiting times in a small convenience store. And our task, we build a simulation model based on the description shown on the screen right now. So after we build a model, we need to compare, different kinds of system performance. For instance, the queue length, the waiting times, or resource utilization. All right, before we begin, could you please make sure that you can access the simulate? And right here, we are on a blank simulation. To avoid losing the data, the first task you need to do is to save the simulation model itself. So you can go to File and Save. Okay, you can name it Model 1. And please make sure that you need to check where you save the file because you will locate the file later on. All right. Next, let's set up the time, how we will run the simulation, right? So on the model description, we need to build the model for a convenience store that open from 8 a.m. to 8 p.m. So we need to revise the time here. The start time should be 8 a.m. and the end time should be 8 p.m., which is 20. And you will see the duration of the day will be adjusted automatically to 12 hours from 8 a.m. to 8 p.m. And the convenience store will open 6 days a week from Monday to Saturdays. So we just change the days per week from 5 to 6. And we would like the time units for the simulations displaying minutes so we can currently keep it as minutes. And we also can specify how we collect the result, the period. We could collect the result after 1 week, after 1 month. But for the demonstration purpose, let's set it up to 1 day. So we have efficient time to learn through the first model. All right, great. And you also can adjust the speed, lower or quicker, so you can see what is happening in your simulation model. Right. So if we read the model description, the customers arrive at the store every 5 minutes on average. We need a start point to show that arrival. So we can drag the start point icon and play it in the window right here. You can zoom in or zoom out to make sure that you can see your simulation model the best. All right, so let's set the property for the start point. You just double it on these icons. Okay, so based on the description, we know that customer will arrive to store at every 5 minutes on average. So the distribution of the arrival time should be average, and the time is 5. So for your simulation, you need to check your empirical data. You need to collect data and analyze the data and justify what type of distribution that the arrival time follows. All right, in this case, that is the average and 5 minutes. Click OK. And we would like to see the name of this icon. So let's name it customer arrival. We can double it in it, type customer arrival. Okay, but we couldn't see the name. So we can go to the brackets ribbon right here and tick showing title. And here we are. We will see customer arrival, right? All right. Also, based on the model description, we know that after picking the items customer want, they will head to the till to check out. And there will be a single queue area that leads to two parallel main tills. Okay, we can create a queue. We just drag it and put it right here. Okay. Of course, to connect the customer arrival to customer queue, you can use edit routing arrows right here. Click on customer arrival icon first, and then click on the queue icon. So you can connect from the start point to the queue. Okay. And if you want to do something else next, you can deselect the edit routing arrows. Right. The same way we name for the icons customer arrival, we can name here customer queue. Just type it customer queue. You can double it on the icon and you will see the queue properties. All right. Okay, to show the name of the object, we can go to click on the queue, go to right click and tick showing title. Here we are. We will see customer arrival and customer queue. Great. Okay, so let's try to run the ever first simulation that we have. We can click on running. All right, so what we see here, it means that in one day, the maximum number of customer we can serve is 143, but we didn't serve anything to them yet. Okay. Right here, there's some strategy that we can manage customer better. In particular, we can create a variable to store some customer information. Okay, let's create a new variable called customer ID. Please go to data and rules, go to labels. We can add a label here and please type customer ID. Usually you can choose the format for that variable, could be number, could be text. And in this case, customer ID should be number. And then we click OK. After creating a variable, we can assign that variable to a specific object. In particular, in this case, when customer enter the store, we will assign them a very unique and specific ID. So we will assign that variable to the object called customer arrival. Right. Now, what should we tell the program about the value of the variables? We can link an action. And customer ID is very unique and specific for each customer. So we can set it unique. Click OK. And click OK. Now we already have the customer ID information. Let's have another type of customer information, which is the time when customer enter into the store. Likewise, let's create another variable using label. Please go to data and rules, go to label, add a label. Let's type time in, right? And time is also a number and click OK. And similarly, let's assign this new variable to a specific object. And in this case, that is when customer arrive. We click OK here. And we should give more information to the program about this new variable. We click add action. So this variable is about the time when customer enter into the store. And let's set it timestamp. All right, and click OK. Right. All right. So we can check what type of information we have after we created two new variables. So let's run the model one more time. And we can click on customer queue, go to properties and see the current contents. So now you will see each customer will have an ID and the time when they enter to the store. All right. And the time here is in minutes, units. So for instance, this customer, the 12th customer, enter into the store at 62 minutes during the day. Great. Okay. Now we need to serve our customer, right? Based on the model description, we know that after the queue, the customer can head to the till to check out. Even though the model description tells us we should have two tills, but for learning purpose, let's have one till first. So let's have the activity and drag it here, all right? And let's name it till one, all right? And let's connect the queue to the till. And to do that, we click on the edit routing arrow, click on the customer queue first, and then on the till again, so we can connect and deselect it before we do something else. All right, excellent. So from here, we need to specify the property for the till. We know that the service times are triangularly distributed, minimum 2 minutes, maximum 7 minutes for the service time, and most of the time the staff at the till will serve customer in 5 minutes. So we can double click on the till and choose a suitable distribution for it. In particular, this is the triangular distributions. Okay, the minimum time for the service will be 2. The most likely time will be 5 minutes, and the maximum time will be 7. All right, we can click OK. And after the customers serve, of course, they will leave the system, they will leave the store. And we can drag the endpoint right here. All right, so let's name it the endpoint. Click OK. And if you want to see the title, again, go to the graphics and tick showing title. Okay, right here we very lightly see very basic simulation model already. All right. All right, so let's run the model one more time. Okay, after running the model, we would like to store the output of the model into an Excel file. How to do that? We can double click on the endpoint right here, choose file. Again, please check the location where you save your Excel file, in particular in CSV format. All right, so I will call it model 1 again, and in CSV format and save. Click OK. And if you want to see the file you just created, make sure that you run the model again, so the data will be stored in the new CSV file. Great. After that, you can use the File Explorer to open the CSV file. Okay, in my case, I store it in the document on OneDrive and simulate folder and try here. Remember, at the start, we save the simulation file already. And here's the CSV file we just saved. We can open it now. All right, good. Right, so we have several columns right here. All right, So we see the customer ID column. We just created the timing variable. We also just created. So what is this column is about? Okay, this column is the result from the endpoint. Basically, that is the timeout. Okay. And I would like to show you one trick right here. You can compute the service time. So basically, we want to know what is the service time for each customer from the time they enter to the store until the time they leave the store. And to compute that, we just take the difference between the timeout and time in. Okay, timeout minus time in, right? And you can do the same for the rest of the customer. So this service time, so basically you will see the first customer, the service time is around 7 minutes, right? The second customer, the service time is around 3.7 minutes. And you can use additional analysis to justify the performance of the service time. You can draw a histogram or do something similar. All right, so now we know how to see the output of one simulation model. All right, so let's come back to the simulate program and continue with our model. Good. All right, I would like to show you some performance metrics you may want to investigate. Okay, so let's click on the customer queue here. Go to the property. Please open the queuing time. Put it right here. Okay, and please open the content tab as well. Okay. Okay. Please do the same for the tier one. Could you please go to the properties, open utilization charts, and please go to tier one again, open the content chart. Okay, great. And of course, for each queue and tier, you can see the result as well. Okay. For instance, for the result for the queue, you will see currently we have no queue in it. You will see the minimum Q value, the average Q value, the maximum Q value, and the total customer already enter into the queue, right? And the same for the tier. You can check the overall result. The current in the tier one is one customer who remain in the system after the closing time. The minimum value, the average value, the maximum value, and the completed job, basically how many customer already served at this tier, which is 142. Right, let's analyze it at more fine range level. Okay, so maybe we can look at the chart a little bit bigger. Right, and the same for this one. Right, so let's run the model one more time. So if you see this message like that, it means that we are trying to produce another output file in CSV format. And for now, you can ignore it. All right, so let's analyze the queuing time, customer queue. On the y-axis, you will see the percentage of customer who waited within each time range. And on the x-axis, you will see the waiting time interval, for instance, from 0 to 1.5 minutes, from 1.5 to 3 minutes. And each bar right here represent how many customers waited within that specific time range. For instance, we can see 48% of our customer waited less than 1.5 minutes. And you can do the same analysis for the other bars. Of course, we have some customer already wait in the line over 10 minutes in this area. Right. The next chart, the contents of customer queue. All right. On the y-axis, we see the number of customer waiting at different time from 0 through 3 customer. On the x-axis, we see the simulation time from 0 to 7. 19. Why we have this number? Remember, our store opened from 8 a.m. to 8 p.m., which is 12 hours duration. And from 12 hours, we can convert from hours to minutes, which equal to 720 minutes. So right here is the closing time of the store. The first impression about this one, we can see the build up of the queue over time. So we can see we might have some problem during the time frame from 360 minutes to 540 minutes, which is equivalent to 2 p.m. to 5 p.m. To know what hour of the day, basically you just convert from minute to hours and consider the opening time and the closing time, right? All right. So on the chart, you can see this horizontal line, which is 0.66. This means on average, there were about 0.66 customers waiting in the queue at any given moment. So you see this is the average line over time. All right, good. Now let's analyze the utilization of the till. So for the first chart, what do you see? We see the waiting percentage in yellow right here and the working percentage in the green color right here, right? So in the green area or the working percentage, it means that the staff or the till already spend 91% of the time to serve the customer. And for the waiting percentage, it means the till already spent around 8.1% waiting for customer to come to serve the idle time. On this line graph, you can see on the x-axis that represents for the simulation time from 0 to 720 minutes. On the y-axis right here, scale from 0 to 1 indicates whether a till is processing a customer. 1 means extremely busy, and 0 just waiting for customer to come to serve idle time. And right here we have that dashed line with 0.94, which indicates that the till is most of the time occupied with a customer. Okay. So it means the till is quite very busy or very highly utilized. That align with the working percentage we can see on the other graph. Okay, so I just show you some basic analysis, but you need to go further than that. You need to look at this result from different perspective for your simulation purpose. All right, great. Okay, let's come back to the model description. So in the model description, we have two tills, right? And right now we only have one till, and let's have the second till. One way to do that is just duplicate, okay? Fortunately, the second tier will have the same property. So we just duplicate this using duplicate wizard, and we should tell them we would like to have another one, and one is already here, and click finish. Okay. So again, the property for this tier is the same as the property for tier 1, so we don't need to change anything about its properties. All right. So let's run the simulation again. Okay, for now, we already have the performance for the queue. We have performance for tier 1. Let's open the result for tier 2. Click on tier 2 icon and open utilization. Okay, and the content, right? Right. Right. So what do we see? We see the waiting time and working time for the tier 2 almost very similar to those of tier 1, right? And the light draft for contents of tier 2 and tier 1 most the same, like 0.5 for the two tiers. So you can see when we have one tier, the ratio was 0.94, and now the busyness ratio is 0.5. So we can see that the dashed line on these two tracks tell us that on average, less than one person is being served at a time. And this strengthened the idea that the till is quite either free, um, like 50% of the time for those two tills. Okay. So in other words, we can say the system probably has some excess capacity that we need to reconsider different policies to achieve the higher capacity or utilization for our system. And on the other hand, if you look at the queuing time customer queue here, so what do you see? The queues improve a lot, right? So the system is highly efficient in minimizing the queuing time. So when we can see 100% of our customers are served less than 1 minute if we have two queues at the same time. And again, I just show you very basic analysis. You need to work on that. You need to analyze more and look at, all the results from different angles. So you can see a lot of insights for your operations. All right, so let me ask you one question. What is the assumption for the current simulation? So the assumption for this simulation is we assume that we have the resource available 100% all the time for these two till, which is not the case. Okay, so let's look back to the model description. We see that we have two cashiers working in shift, right? All right, now let's specify the resource. We can write the resource into the window and put it here. So let's name it cashiers. Okay, great. And if you read the model description, we know that we have two cashier. Will they work in shifts or not? Yes, they work in shifts. So we can take on shift dependent right here. And we can specify the shift work patterns. Okay, so what is the first shift? The first shift is the day shift, right? So let's create a new shift. We call it day shift. And in the day shift, the cashier will work from 8 a.m. until noon. All right, specify 12 right here. And they will not work every day. Where we work 6 days a week, we can specify the weekly patterns from Monday to Saturday. We can untick the Sunday here and click OK. And after that, we can create a new shift patterns. And let's call it afternoon shift. All right, and we can specify the duration for this shift, which is from noon to 8 p.m. It's exactly what we want. And again, the store will open from Monday to Saturday. We can untick the Sunday here. Right. All right. And remember, we have two cashier. We have one person we work in a day shift, so we can specify that we have one person for the day shift. And for the other shift, we have another person. Right. We can click OK again and click OK. Good. So now we already created that we have a resource which is two cashiers, right? But we need to assign the resource to the server right here in the simulations. Okay, to do that, please click on T1 and go to resources and we add the resource cashier. Okay, okay, and okay again. And if you click on this one, now you see the highlight for T1. It means that we will use the resource from cashier for T1. And let's do the same for T2. We double click on T2, go to resources, and we add cashier here, right? Good, right. And we can click on cashier again. You see, this time both tills are highlighted. It means the resources are assigned to both tills. All right, so please remember the number very quickly and we run the model again and let's compare the results after we assign the resources, okay? For now, please remember that when we didn't specify the resource, 100% customer waited in the queue for less than 1 minute, right? And each tier working only 45% of the time and waiting for 54% of the time. Okay, so let's run the simulation one more time. Right? All right. Now you see some change happened already, right? First, for queuing time, customer queue. Remember when we didn't specify the resource, the waiting time is 100% customer waiting less than 1 minute. Now things change. We only have 56% customer waiting for less than 1 minute. Some of them even waited for more than 5 minutes right here. Okay. And we also see the build up of the queue size over the time. So right here at 360 minutes, roughly at 2 p.m., that's quite a big time for the convenience store. We see a lot of customer queued here at this hour, right? All right. And on average, there were about 0.37 customer waiting in the queue at any given moment. It means there's some gap time, okay? There's no queuing at all. And there's sometimes a lot of people queuing for the till, right? Excellent. Okay, that's how we analyze the queue. Now let's move on to T1, okay? And T2 as well. You see something new shows up here. That is the resource starve, which we didn't see in previous simulation runs, right? All right. So from now, we see that each till working 45% of the time and idle for 40% of the time. And sometime we have customer available in the queue, but we didn't have enough or efficient number of cashier to serve, which is around 14% for each tier, right? And also similar to the previous simulations. So we have the dash line 0.41, 0.48 here. That tells us on average less than one person is being served at a time. So basically we have like probably a lot of time the till is available without customer. All right. So again, the system is quite efficient in minimizing the queuing time. But somehow each till here are under the expected capacity or underutilized. So you need to adjust a lot of policies or strategy to meet your expected capacity for your systems. All right. So now if you check the model description, especially model one description, we already satisfy all the requirements, okay? So you can learn the software, you can run the simulation, but another task is quite important again, that is your analysis. So from analysis, you can inform how will you change the system, how create another scenario of the optimal system that you want. And another tip, please always save your file. Either is it the simulation.s8 file or is it an Excel file? You can send those files to your email just for the record. As well as you can save on the chart right here. You can copy the data. You can copy the image to the clipboard. All right. So before I end this video, I challenge you to run the simulation not in one day, in 1 week, in 1 month. Can you try that? Right? And another thing you can try as well, okay, instead of specifying the customer inter-arrival time is 5 minutes averagely. So imagine after you run a lot of promotional campaigns, people get to know your store better. You collect the data at your store and you figure out that now customer will arrive your store at 4 minutes averagely. Okay. Now let's run the simulation one more time. All right. This is interesting, right? You see something new here. Okay, we have around 21 customers still in the queue, even we already closing the store in one day. Okay, so as a managers, you need to think of solutions for this circumstance.